Okay, so this is the homework set on Chapter 6, Section 1, where we're dealing with organizing quantitative data. And so the first problem is from the book. It's giving us a small data set, and it's asking us to find the mean and the median. I took out the mode. We're not going to worry about that so much. And so to find the mean, I don't have to do anything with the data. I can just go ahead and add up all the data values, divide by the number of data values, which is 8, and I'll get 86.875, which they want me to round to one decimal place, so that'll be 86.9. If I'm going to round that off to the first decimal place. Okay, then they ask for the median. Well, I have 8 data values. I have an even number, so I have 2 middle values, 86 and 88. I take the average, I'm going to get 87. Okay. All right, the second problem is looking at the mean and the median again, and we're given a bunch of home prices. And to find the median, that's very easy. I'm going to go ahead and notice I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the fifth value will be the middle one. And I have to make sure that the data values are ordered, but they are. And finally, I'm going to find the mean. So I'm going to add up all these data values. And notice I don't have to put thousands because they're automatically all going to be in thousands. I'm going to leave off the 0, 0. And instead of adding 120 3 times, I'm just going to say 3 times 120. So that'll make the calculations a little quicker. I take that sum, divide it by 9, and I'm going to get 126.8, which rounded to the nearest thousands, because this is in units of thousands, is going to be 127. Okay, the next problem is asking us to find the mean and the standard deviation for data about the number of employee absences each week over a period of 10 weeks. So let's go ahead and take a look at that. I'm going to compute the mean first. So I'm going to add up all those values and divide by 10. The mean's 3.8. And now I'm going to compute the standard deviation. And so this is the sort of thing that I'm going to ask you to do on the exam. I'm going to give you a table. It looks just like this. And you're going to go ahead and fill it out. So I'm going to enter the data values. And then I'm going to compute this thing called the deviation. This is the data value minus the mean. Okay, and then I'm going to square that. And I'm going to keep a running sum. So for the first value, the sum is going to be 0.64. Take the second value, the deviation there is 1.2. Let me go and center these real quick. These values. Okay, I square that, I get 1.44. I'm going to add that to the old sum, add these two numbers, and get 2.08, and keep doing that. Now, if you have a store button on your calculator and you know how to do this, you don't have to have this last step. And I just keep doing this. Subtract 1 from 3.8, get minus 2.8, square that, get 7.84, add that to 2.08, and get 9.92. Just keep on doing this. And the very last value gives me the total sum squared deviations, 29.96. Now I'm ready to compute the standard deviation, because I know the standard deviation is the sum of the squared deviations. The total is 29.6 divided by the number of data values, which is 10 minus 1, so I have 9 down here. Take that square root, I get 1.813, which I round to 1.81. I believe it asks us to round it to 2 decimal places. And the next problem is very similar, except we have less data values. We're given some quiz scores, 4 quiz scores, and we want to compute the mean and standard deviation and round the standard deviation to 2 decimal places. So again, I'm always going to find the mean first. Add them all up, divide by 4, get 79.5. And now I'm going to go ahead and just complete out the table. Take that data value, subtract it from 79.5, get minus 4.5, square that, get 20.25, and put this in my running sum. This is going to be where I add up all the sum of the squared deviations. And I do just like last time, basically. I create this same table the same way. And now I get the standard deviation. It's the total sum of squared deviations, which is 413, divided by the number of data values minus 1, which is 3, and I take the square root of the whole thing, and I'm going to get 11.73. And then I round that off to 11.73. Okay, so problem 1 is from the Excel sheet on the homework, and it's giving you the difference between the winners and the losers, the number of points in each Super Bowl game. I already ordered the data, and now we want to make a histogram using a bin size of 5, and then use the 5 pieces of information. And here I asked you to not compute the standard deviation. It's a lot of work. So it turns out that when you take this histogram and you plot it in bins of 5, you get something like this. So these are the 5 things we need to talk about. We need a number of modes, and it looks like it's unimodal. It looks like that plot is kind of fitting something that looks like this. It's a curve that, whoops. I didn't want to do that. Let me try this. We can see it's kind of following a curve, something like that. It's not exact, but so this looks unimodal. I'm going to try to draw a straight line through that. That's probably or try to draw a nice curve through that. It's probably going to look something like that. It's going to be right skewed because it definitely has a tail to the right. And this I'm going to compute when I do the histogram, but for right now, just know that the median's 12, the IQR is 15. When we do the histogram, when we do the box plot, we'll automatically get these two things, right? And as far as outliers, there doesn't appear to be any. In other words, there's no data value that's really far away from the rest of the values. This value just has one gap, but he's really not that far away. So we're going to say that there do not appear to be any outliers. Okay, let's take a look at the box plot now. So we go ahead and we know the values are ordered. We can easily get the max and the min. The 1 and the 45 are easy. Next thing I'm going to do is I want to find out what the median is. So I'm going to use the fact that if I look at this, okay, I have 51 rows, but the first one is taken up by a label. So I really have 50, which means I have an even number. So the median is going to be the average of these two middle values, which both happen to be 12. So my median ends up being 12. Now I go back and I realize I have 25 data values here, so 13 is going to be the middle data value for the lower half. I use 12 because 12 was used in the computation of the median, but it's not the median. So I use this whole data set as my lower half. And since I have 25 values, the middle value is 13. And so the first quartile ends up being 4. Now there's a little trick you can use. I noticed that when I subtract 13 from 25, I have 12. Which means if I add 12 to 26, I'm going to get the third quartile. It's going to be the 38th data value. So you can subtract off this ranking 25 from the ranking of Q1, which is 13, get 12, and then just add that to 26 because it has to be symmetric. So when I add 12 to 26, I get 38, and that's the third quartile, 19. Now, once I have the 5-number summary, I'm ready to do the box plot. Notice it's actually backwards in the histogram. The histogram, we make the plot, and then we give the summary statistics. For the box plot, it's the opposite. We give the summary statistics, then we make the plot. So first I need the IQR. I'm going to take Q3 minus Q1 and get 15. Then I'm going to compute the whisker length, which is 1.5 times the IQR, and 1.5 times 15 is 22.5. Then I'm going to compute the upper whisker value, which is going to be the third quartile plus the whisker length. That's 41.5, which is up here. I compute the lower whisker length, which is Q1 minus, lower whisker value, sorry, which is Q1 minus the whisker length. It's minus 18.5. And now I'm going to plot all the data values between here. But first I'm going to plot the box part. We always start with the box. So I'm gonna make a number line. My values go from 1 to 45, so this goes from 0 to 50. I'm going to plot the box part, which is Q1 down here, which is 4. It goes up to Q3, which is 19. That's the border of my box. And then the median, 12, is a line that goes right here. Now I'm going to plot all the data values within minus 18.5 to 41.5. And you notice that 1 lies within here. So the lower value is going to be 1. But notice that the data value within 41.5 happens to be, if I go back to the chart here, happens to be 36. That's the value within 41.5. And so that's going to be the end of my whisker. So what happens to 45? He's an outlier. He's more than 1.5 whisker lengths away from Q3. And so I put a little dot there for him at 45. Okay, let's take a look at the next one. So here we're given the number of home runs hit by the Baltimore Orioles each year since they came into being till now. And first we want to make a histogram using a bin size of 20 and give the 5 pieces of information that describe the histogram. And so I'm going to go ahead, I'm just going to make bins of 20. I'm going to be careful how I do the inequality. I'm going to choose to put the less than or equal to rather than having it less than and then less than or equal to up here. I'm going to put the less than or equal to on the left-hand side. And notice that I'm consistent. And I just count the number of data values in that interval. Okay, and you go ahead and plot it. It's actually hard to describe this plot. This is a plot that's not very typical of anything we've seen. The number of modes is questionable. It seems unlikely that it's unimodal. Okay, it seems very unlikely that 14 is way up here and these two are 5. And in fact, if you go back and you look at the data, you see that the really low home runs, okay, it almost appears to be kind of bimodal. There appears to be a period where there really weren't a lot of home runs. Most likely this is when baseball first started. The number of home runs really weren't all that great in the beginning. So this is probably bimodal. This is probably the initial phase when there weren't a lot of home runs, and then afterwards when there were. If you said unimodal, I probably wouldn't take off points, but this is really bimodal. What is the shape? Well, the shape's not anything that's easy to describe. The most important thing is that it's not symmetric. That's important. We always say whether it's symmetric or not. It's probably right skewed, but it's a little hard to say. We can't really say this with any strong degree of certainty. The most we can really say is that it's not symmetric. Again, I'm going to get the median and the IQR from his histogram when I do that. And again, outliers, there don't really appear to be any. There's this one value that's way out here, but it's only 1 DIN away from the rest of the data. So again, we would say there's probably not any outlier. And we're going to see when we do the histogram if that's actually true. Notice for the first problem, we actually got conflicting conclusions for the outlier. Here we said that there doesn't appear to be any. Whoops, sorry, up here. We said there doesn't appear to be any, but actually when we did the histogram, we found out that technically there was. So when we're looking at the histogram and we're talking about outliers, it's kind of a judgment call. Okay, if I were to look at this histogram, even though this is an outlier, I wouldn't know this. So this is one of these situations where we just do things visually. This doesn't appear to be really far away, so we say it's not an outlier. But when we actually do the box plot, we find out that technically it is. Okay, so when we do the box plot, we can unambiguously say whether it's an outlier. When we do the histogram, we just have to make a good guess visually. Okay, back to the plot here. So again, we'd say there appeared not to be any. And we're going to find out for this problem actually that's true. But again, it's kind of hard to say. It's a judgment call when you're looking at the histogram. Okay, so now we're looking at the same data. We're going to do a box plot though. So the first thing we do is we do the max and the min. We're always going to do the 5-number summary first. They're already ordered, so I can pick off the max and the min. And now I have to find the median and Q1 and Q3. So the first thing I'm going to do is I'm going to figure out how many data values I have. I have a lot. Okay, I have 110 data values, but the first one is taken up by the label. So I really have 109, which means that 55 is going to be my middle data value. Now, if you're not sure how to do that, here's one way you can do this. I can take 109, divide it by 2, and round up. So this is a good rule of thumb if you have large numbers like this. So I could take 109, divide it by 2, and round up. Another way to do it is that really 109 is actually 1 plus 108. And the 108 have to lie on both sides of the median, which means there has to be 54 on each side of the median. Okay, which means that this has to be the 55th data value. And hold on a second. That's wrong, because the 55th, I have to add it here. I looked at the number, but I didn't take into account the fact that there is actually a label. So let's go back for a second. So we have 109 data values. The middle one is going to be the median. And 109 means that there's 1 plus 108, which means there's 54 on each side. So 54 plus 1 is going to be 55. But because the first one's taken up by the label, it's actually going to be 56. So this has to get changed to 106. Okay. Now I got to find Q1 and Q3. So I'm going to use the fact that I know there are, and I can't use this in the calculation of the upper and lower halves because it is, the median is a data value. I know I have 54 on both sides. Okay. So 27 and 28 are going to be the middle data values. But since I have 1 for the label, it's actually going to be 28 and 29. So it's going to be these two. It's going to be the 27th and 28th data values, but the first line's taken up by this, so it's actually 28 and 29. So this doesn't change. This is still 63. Okay, now let's go back to here. Now we have to find, so we have to be a little careful. So I'm going to notice that here I have 29 and 56. And if I subtract 56 from 29, I'm going to get 27. Okay. So what am I doing here? So I'm subtracting this from this because I'm going to add the same difference on the other side to get this value for Q3. Okay, so 56 minus 29 is 37. I add 37 to 56. I'm going to get 73, which is really, hold on, I'm sorry. What did I say here? I have 27 here, so I'm going to add 27 to 56, and I'm going to get 83, sorry. And so, since I have the first one taken up by a label, this is going to be 83 is going to be actually 84. It's going to be 84 and 85. So it's these two values right here. Okay. So again, 83, but the first one, no, I'm sorry, this was right. Just be careful. So I'm adding 83 to this. I'm adding 27 to this. So 20. Hold on. Yeah, I'm adding 27 to this. And now this is going to be the right label. So 27 and this is going to be 83. So it's going to be 83 and 84. Yeah, that's right. So you just have to be careful when you do this is all. Okay, so that data value is now going to be the average of 156 and 156, which I know is 156. Change that real quick. And now I'm ready. So first I'm going to look at the IQR. I'm going to take this difference, 156 minus 63. Okay. and I'm going to have 93, and I'm going to compute the IQR. So that's just going to add 3 to this, 139.5. And it's not going to change anything when we go ahead and I compute the upper and whisker lower values. I'm just going to add 139.5, which is just going to add 3 to this for the upper whisker value, and it's going to subtract 3 from this. Okay. And so now I want to find the data values between minus 78.5 and 293.5. Okay, the first thing I notice is that I don't have any outliers. All my data values lie between here, so I'm okay. So I'm going to draw my box first. My box is going to be from 63 to 156. So it's going to change a little bit. 63 to about 156 is about there. I'm going to start at the minimum because 5 is within that lower whisker value. I'm going to go from 5 to the end of the box here. Then I'm going to draw the upper whisker from the top of the box out to the largest data value within 293.5, which is 257. And there's my box plot. Okay, the other two problems we'll do in class. We'll puzzle through those on Tuesday.